Good day, sir. We are from Group 4 and our project is called Smart Blood Donation. So now I'll be talking about the architecture diagram of the solution that we propose. So based on this architecture diagram, you can see that there are two different color of line. One is in green color and the other one is black color. The green color line will represent the admin, which is the hospital employee, while the black color line will represent the user or the donor. So first of all, the admin will use this system to post the blood donation request to all the nearby donor or users. So when the request is posted, the Amplify will redirect the request to its respective API gateway to trigger the Lambda. And then the Lambda will retrieve the location of the hospital and the user from the database for comparison purpose. When they are donors who are within the 10-kilometer radius of the hospital, then the request will be sent back to the donor through the Amazon SNS. A response will be sent back to the amplifier to tell the admin whether the request is successfully broadcast or not. And then both user and admin, they can sign in into with their respective account before they can use the features provided by the system. The authentication part is done with the help of Amazon Cognitor. And then email and password are needed for sign in into the account. And then a new user need to be sign up their account before they are able to use the application. Then for the admin, new admin will be added manually by the developer. Next, when a user sign up for an account, he or she will need to confirm the account by inserting the code that's sent by AWS Cognitor. That's AWS Cognitor will send a code to their email that is for registration purpose. So after the confirmation has been made, the Amplify will send the user data to a specific path in the API gateway to trigger a Lambda function to store the data into the database. So that's all for my part. Now I will pass to the next teammate to continue the explanation of this architectural diagram. Thank you.
Good day, Dr. Chung. My name is Lim Xin Hui. For the rest of the part, when the user logs into the system, another Lambda will be triggered to retrieve the user data from the database. When the user edits their profile, another Lambda will be triggered to update their profile in the database. In order to verify an account, an image of the user identity card and his or her selfie are required. The users must permit the system to retrieve images from their gallery before this could be done. Two of the images will be uploaded to the S3 bucket and a Lambda will be invoked for the verification process to call the recognitions to compare the faces in the identity card and the selfie. Only users who verify his or her account is allowed to request for their blood report. When a report is requested, a Lambda will check for unopened report in the database and send it to the user email through Simple Notification Service SNS. When all the reports are open or no report are found, the application will notify the user that no report is sent. A survey feature is also provided to the user to ease the blood donation registration process. When a survey is completed by the user, a Lambda will be triggered and result of the survey will be stored in the database. Moreover, another Lambda will be used to generate the cert that will last for that particular day to prove that the user is valid to donate blood. The user will be able to view the cert through the cert tab. The cert will be fetched from the database and validated by a Lambda function before it is shown to the user. Last but not least, Amazon QuickSight are used to analyze the data in the database and process the data into useful information. Dashboard could be created with QuickSight, which could help developers convince their stakeholders and get more sponsors for the development of the system. That's all for the architecture diagram, and I will pass the presentations to the next presenter to demo the system. Thank you.
Good day, sir. I'm Hiding, and I will demo some of the use case for the smart blood donation system. First, new user will have to sign up before he is able to utilize the function provided by this system. Email and password are required for signing up. Once the user clicks on the sign up button, Cognitor will send a confirmation PIN to the user email. Upon entering the PIN, a user profile will be created in the database. The users will also have to confirm two of the emails to subscribe their account to the SNS topics. This ensures that SNS could broadcast the message to them when needed. Therefore, the user email will be shown here. The user are not allowed to change their email, however, they could update their name and their IC number. In order to update their data, they will have to click on the update button upon entering that information. A Lambda will be invoked to update their profile in the database. Therefore, when we click back to the profile tab, after clicking another tab, that the updated data should be shown here. By clicking the survey tab, user will be prompted to finish a few survey questions. This survey question will determine whether a user could donate his or her blood or not. When the user is eligible to donate blood, a cert will be generated in the next tab. This cert is only available for that particular day. Now, let's redo the survey to simulate the case when the user is not eligible to donate the blood. When the user is not eligible, the cert lab will remain unchanged. That's all for me. I will pass the presentation to Wei-Jing to continue the remaining part. Thank you.
Good day, sir. I'm Wei-Jing, and I will present the remaining demo part of our applications. So the first function that I will be demoing is the compare picture function. This compare picture function will compare two images, which one is the IC and another one is the selfie of the user. So before comparing the image, we have to allow the system to get the picture from our database to get the pictures for our applications. So after clicking two pictures, we'll click on the compare picture functions, and a Lambda will be invoked to compare these two images. Once these two images are similarity is having 99% or above, it will say account verified. Next, the user will be able to post the request to get the upload report. And if the report is available in the database, it will be sent to their email. So now the record is not found. So let's stimulate a report that will be found. So I will try to edit the database. So I will change this to I will use another account instead of this one. Because this account has a report. Then in the meantime, I'll change this to false. Then I will post request again. Okay, so I will receive the blood report in my email. So refreshing this, here is the blood report. So next, I will be showing the admin function that is available in this system. This is the admin account. After log into this admin account, the admin is able to post the blood donation request through this button. So by clicking this button and then wait for a while, and here blood donation request has been posted. So users that are accepting the SNS topics will receive the report, but only users that are within 10 kilometers will receive the record. So for this one, the user is 10 kilometers within the 10 kilometer radius of the hospital. So he will receive email something like this. So upon clicking this, it will send response to our database that saying this user will join the blood donation. So let's try another account. So for this one, since this user is not within 10 kilometer radius, it will not receive the donation request. Okay, that's all from our team. Thank you.